In these videos, I'm going to help you study for the EOCT test in analytic geometry. Your teacher should have given you a diagnostic test. I'm going to go over problems similar to the question on the diagnostic test, and then you should be able to answer those questions on that diagnostic test. Alright, let's get started. Now, problems 1 through 3 in this video have to do with dilation of geometric figures. So let's start problem number 1. We are given triangle A prime, B prime, C prime, and it is a dilation of triangle ABC by a scale factor of, well, notice ABC is smaller than A prime, B prime, C prime. So that means our scale factor has to be greater than 1. If we look at segment AB on our small triangle down there, you'll notice that it is three segments apart. Now, if we go over there and we look at A prime to B prime, if you count that, it's 9. So we have increased AB to A prime, B prime by 3. The dilation center is at the origin. We'll look at that on problem number 3 even closer. One of the things that we studied is setting up the ratio of corresponding sides. Alright, let's look at the two triangles. We're going to have triangle and triangle prime. Now, when you set these up, you want to come in and you want to set vertically in one ratio on one side of the equal sign everything you know about your first triangle. I've said we have side 1 and we have side 2. Then you set it up equal to your prime triangle. Again, notice side 1 goes with side 1. Side 2 goes with side 2. I hope you can see the ratio there. That's just for general. I also set it up for this specific triangle. Notice on the left hand side it was the original triangle, AB over BC. What did I set it up equal to? On the top, A prime, B prime. On the bottom, B prime, C prime. Remember, to solve these problems, we cross multiply. Okay, stop the video. Do problem number 1 on your worksheet. Alright, you should notice that problem number 2 uses the same triangles that we had before. We still have triangle A prime, B prime, C prime is a dilation of triangle ABC, and its scale factor is 3. The dilation is centered at the origin. Now, what they want to talk about this time in problem number 2 is what is the ratio of the area of triangle A prime, B prime, C prime to the area of triangle ABC. Okay, what do we do to the area, or what can we do to the area of ABC to get the area of triangle A prime, B prime, C prime if we know the scalar? Alright, let's do this. First of all, we've got to find the area of ABC. That's where I want to start. Second, I want to go get the formula for area. Area equals base times height divided by 2. Now, if you look at the coordinate plane, you can actually physically count the base and the height. The base is 3 and the height is 5 on triangle ABC. Now, we're going to plug that into the formula. There you go. I'm going to work it out just to A is 15 over 2. Alright. Now, let's look at triangle A prime, B prime, C prime. Alright, we want the area of it. Get the formula. Now I'm going to do something weird here. I'm not going to count. I could do that. Okay, and you might want to count and find out what it is. I'm going to take the original information. It says B is 3. The base for ABC was 3, and the base for triangle ABC was 5, and I'm going to multiply it by the scalar. This is what I'm talking about. The base of the original triangle was 3, right? And I'm going to multiply it by 3. Why? That's my scalar. The height of the original triangle was 5. What can I multiply it by? 3. That's my scalar. I'm going to plug that in. Oh my gosh, that looks a little strange, doesn't it? Notice I put the scalars in red and the original triangle in black. I'm going to multiply the original ones together and the scalar together. Okay, so really we can multiply 15 times 9 and divide it by 2 and actually find out the area. But we're talking about the scalar here. What did I do to 3, my scalar, to get 9? I squared it. Okay, so if I had a scalar of 10, you know, triangle, my original triangle, the area was like 4, and I have a scalar of 10, I'm going to square 10 and get 100. That's how much the area is going to increase. It's going to increase by 100 times. Now if I had something like 1/5 as my scalar of my original, right? I'm getting smaller. I would still square 1/5. And how much is that area going to decrease? It's going to decrease by 1/25. Okay? Area and scalars are squared. Hope that helped a little bit. Stop the video. Do problem number 2 on your worksheet. This is problem number 3. On the coordinate plane, we have segment M prime, N prime is the result of the dilation of segment MN by a scale factor of 1/4. Notice that the original one is bigger and it gets smaller. The segment gets smaller. That's why you have a fractional scale factor. Now this says, which point is the center of dilation? This is really easy if you have a straight edge. Now, they usually don't give you a straight edge during the EOCT. But you know what you have? You have your ID, okay? So you can take your ID and what are we going to do? We're going to draw a segment or a line through N prime and N. Then you're going to draw another line through M prime and M. Where do those two segments intersect? 0, 6. That is your center of dilation. Stop. Do problem number 3 on your worksheet. This is the end of this video. There'll be another one for the next problems. Bye guys.